Hey everyone, welcome. My name is Federico Kunze Küllmer. I'm the co-founder and CEO of Evmos, which is an EVM on Cosmos. Today I'm going to talk about what Evmos is and why we think it's the next frontier for EVM development. I'm going to start a little bit with what is Evmos and what's its architecture. Evmos is a Cosmos SDK-based chain. The Cosmos SDK is the framework that Cosmos have for creating application-specific blockchain. In the case of Evmos, we have an EVM module, which is where the core functionality that allows us to run smart contract and allows us to have this EVM module talk to IBC, thus making smart contracts fully interoperable with the rest of the IBC ecosystem and the Interchain ecosystem. Just going to explain a little bit what the Cosmos SDK is and how it talks to consensus. We have here on the left side, we have Tendermint Core, which is the consensus engine that runs PBFT, proof of stake consensus. So how the application communicates with the consensus engine is through an interface called AVCI that stands for Application Blockchain Interface. So the application itself handles all the business logic or all the, in this case, like the EVM logic running supporting smart contracts. You can also see that we have a staking module, Web3, which is in this case like the JSON RPC to fully support all the Ethereum tooling. We also have like a governance module. So like this is all handled on the Cosmos SDK in all these modules that sit on top of this framework. And then the application itself sends the updates and communicates with the consensus so that the transactions can be verified and, well, where the gossip of the different messages and transaction occurs between like the different validators and node operators. So just to quickly summarize, Evmos is a Cosmos-based chain that has an EVM module that fully supports EVM and smart contract interoperability through IBC. One of the main components besides the EVM is the IBC component. We've now seen a lot of chains sparkling in the ecosystem, and you can see here how the different connections between these IBC ecosystem can be handled. Right now, one of the most important applications that sits on top of IBC is like the ICS20, which stands for the fungible token transfers between different chains. This is different than creating a bridge architecture because it's fully trustless and different chains can communicate with each other by running like light clients of all the different chains and thus verifying the macro proofs against each other. We think that Evmos is going to be the main point of entry for all the developer adoption in the EVM ecosystem. Because if we start thinking about like interoperability, there are three major interoperability clusters right now in the blockchain ecosystem. The first of them being the EVM ecosystem with all the EVM chains that are in Avalanche. We have Ethereum, of course, and then we have like other EVM siloed chains in Polygon, Gnosis chain, etc. Then we have on the other interoperability cluster, which is Cosmos with the IBC protocol, and then we have Polkadot with cross-chain message passing. And through Evmos, we'll be finally able to connect all these different clusters of interoperability that are right now in the blockchain ecosystem that previously weren't be able to connect before. There were like EVM bridges, but we are a fully interoperable EVM chain running on Cosmos. So we can send transactions to other EVM chains, we can send transactions to other Cosmos chains, and through Moonbeam, we can also talk to other chains in the Polkadot cluster of interoperability. Evmos is not only going to be an EVM application-specific blockchain, but it's also meant to be an EVM hub. In the Cosmos ecosystem, we define hubs as the chains that can create, that other chains can derive security from, and thus we can create like a healthy ecosystem of EVM chains where Evmos sits on top and other chains can also talk to through IVC by creating, like, for example, cross-chain delegate calls or cross-chain contract calls. And the Evmos share security model will allow all the other chains, being EVM chains or non-EVM chains, to derive security directly from Evmos by sending validator set updates to the counterparty chains, in this case, like the consumer or child chains, that will be able to share the same security that the Evmos core validator set provides. Now I'm going to explain a little bit about the token model and why we're different than any other EVM chain you've seen before. So back last year, when there was this whole debate during the London hard fork about miners versus developers trying to push for or against the EIP 1559 adoption, there was this major push from the developers to try to increase the user experience because you are basically creating Ether as the base fee token model of the entire Ethereum ecosystem. Whereas previously before, the user experience for the user was that when there was a sudden increase in the demand for block space, you have to wait for additional confirmations, or you had to resend the same transaction with a higher gas price. So by creating EIP 1559, you have like a fee market where you can have a more predictable fee for your transactions, and thus improving the user experience for all the users that are using Ethereum. But there was this huge misconception from the miners, how they saw the developers and the power they had in the Ethereum ecosystem. But developers, core developers in this case, are only one part of the entire community on Ethereum. So you have all the holders, the miners, the developers, but you also have the application developers that deploy their dApps to Ethereum, and you also have the DeFi users that are interacting with these applications. So before EIP 1559, there was the fees that went directly to the miners, and you had the block rewards that also went to the miners. When EIP 1559 was introduced, the base fee was burned, and the tip, which was a priority tip to include your transaction faster, was allocated to the miners. But of course, the miners weren't happy when they were some portion of their fees were taken from them and burned. So they went against the developers. So there was this huge drama last year of adoption or not adopting EIP 1559. But as I said here, developers are only one part of the Ethereum ecosystem. So that's why Evmos decided to create long-term sustained growth of the protocol by aligning all the different actors in the ecosystem, developers, validators in this case, because Evmos is proof of stake, and then we have the decentralized application developers, and we also have the stakers and decentralized application users. We are doing this by introducing the first dApp store. So the dApp store is a decentralized marketplace for dApp developers and users, where, as opposed to EIP 1559, that is burning the base fee, we're splitting the base fee between the miners and the developers. That means if your application is successful on Evmos, you will share 50% of the transaction fees for all the transactions that interact with your protocol. This is a major change because we're finally incentivizing all the developers to align in the long term with a protocol, a layer 1. And we're turning the protocol itself to also be a layer 1 that is focused on consumers that are using the applications, as opposed to focusing entirely on developer experience. So we are trying to incentivize the developers and all the users that are in the protocol. So the other side, now I explained the developer side of the dApp Store marketplace. And we also have like the usage incentives. How traditionally, developer incentives and user incentives have been done through different DeFi programs or DeFi incentive program or liquidity programs where different foundations put like millions of dollars for users to provide liquidity on different applications. But the main limitation is that these are not sustainable in the long run, are usually like selected applications which are sometimes not transparent in the decision process of which is actually the criteria for these applications to belong in this list of DeFi incentives. And the main problem as well is that it's not community owned. So the community cannot vote on which are the incentives and for how long, or which are the applications that are going to be allocated these user incentives. And the main problem as well that we've seen in the DeFi incentive programs is that the TVL doesn't really reflect the traction of the protocol or the users that you're getting. So TVL doesn't mean that you have more users. That's why instead of creating these unilateral DeFi incentive program, the Evmos token model is allocated a percentage of all the tokens that are going to be minted to allocate them to user incentives. What does this mean? That the community can vote for which are going to be the projects and the smart contracts that are going to be incentivizing, And what do I mean by incentivized? Here, we're taking the same approach that you can find on all the DeFi apps that you can have LP pool incentives or LP incentives like you can find on Osmosis and other AMMs. We're doing the same for smart contracts. So I'm going to explain now the workflow of how developers can register their contracts for their users to get all these usage incentives. So any developer or user or member of the community can register an incentive proposal via governance. So for example, I'm going to allocate 5% of all the newly minted Evmos tokens from these 25% that I mentioned before to my contract that is going to be distributed every week for a duration of 6 months. Once the proposal period passes and this proposal is approved, every transaction that targets this smart contract will start aggregating the gas spent in these gas pools. So as a user, you'll have like a share of the total amount of gas spent, and then you're going to get pro rata the gas that you spend from these 5% of newly minted Evmos. So all your users are going to get basically like it's a deferred gas rebate that can actually be larger potentially than the amount of gas that you spend. So you're basically incentivizing your users to spend more transaction fees and interact with your contract. So this is really important, like creating and incentivizing this two sides of the marketplace, because like developers can propose user incentives to promote the growth of their decentralized applications. But then these incentives as well drive new users and reward them with more Evmos tokens, where these users that receive all these rewards can spend these Evmos tokens on the decentralized applications and different projects and services that Evmos provides. And through the dApp Store mechanism, the developers will get 50% of these transaction fees from all the contracts that are incentivized, from all these contracts that they're already deploying. So you're getting 50% of the transaction fee for your project, and you're also incentivizing your users to use your application. So this is creating a positive reinforcement cycle where like new users attract, like spend more transaction fees, and then you have like all the incentives that are promoting more growth. So it's like a positive reinforcement cycle to promote the long-term alignment of the users and developers with the ecosystem. So the Evmos token model is basically trying to align all these incentives with all the different users that we can find in our ecosystem and on the EVM ecosystem. So we have like the holders that can stake or LP their tokens, the DeFi users that will be provided rewards through these usage incentives. Decentralized application developers will have this dApp mechanism where they can get, as I mentioned, 50% of the transaction fee, and this can actually go up if voted by governance, because it's a fully configurable parameter. Whereas core developers, grants, and community pool treasury that can allocate additional sources of funding to booster the adoption and boost the development of the core protocol. And then for the validators, they'll still have 50% of the transaction fees for all the transactions that target the EVM. And they also have like the block rewards from the validation services that they provide. Now, I'm going to talk a little bit about liquid staking. This is a topic that is very interesting in what's happening right now in Cosmos. So liquid staking, for context, staking itself initially in 2019 was introduced by Cosmos as like the first DeFi use cases, the first DeFi use case in the entire Cosmos ecosystem, because IVC was not live yet. So when we think about liquid staking in the context of an EVM, we can think about the lightest architecture, where you can have like the staking contracts that they allocate the ETH directly to the Ethereum deposit contract for the beacon chain. So the users, when they deposit their Ethereum, they get like staking ETH in exchange. But the main limitation in Cosmos as well is the liquid staking implementation is not a smart contract. So that's restricting all the smart contracts, which are also accounts from actually staking. So for Evmos staking B2, we're doing something completely new. As I mentioned, B1 was just a Cosmos delegated proof of stake mechanism. But with liquid staking, we want users on contract that can stake different Evmos tokens. So users can, through Kepler or MetaMask, can delegate their tokens to the different validators, but we want also smart contracts to be able to create different DeFi applications that are targeting specifically staking, so that we can have a more secure validator set, providing security for all these different chains in the entire interchain ecosystem. I'm going to elaborate a little bit more when I talk about the different use cases that Evmos is introducing that are super novel in this sense of staking and sloshing. But yeah, I'm going to continue now with how we're making ERC20 tokens fully interoperable. So when we go back into the architecture, we find that the Cosmos SDK has different modules. These modules can talk to each other, but the main restriction with this architecture right now is that in our case, the EVM is completely isolated from talking to these other modules. So what we introduce is like a post-transaction execution logic that allows custom logic for how to execute different behavior after an Ethereum transaction is processed. In our case, we're allowing Ethereum ERC20s to be fully interoperable with the entire interchain ecosystem. How are we doing that? By creating like some sort of token pair where you are mapping an ERC20 smart contract with a Cosmos denomination. This is all voted through governance. So if you have like 100 IVC voucher atoms, you can vote through governance on what is the canonical representation of the atom in the EVM. So basically here what we're creating is through a governance proposal, the community votes on what's the canonical implementation of an ERC20, and then you can, after that's approved, you can start converting from Cosmos formatted coins to ERC20 tokens in the EVM. That allows all the ERC20s that are going to come from all these interchain clusters from the Polkadot ecosystem and the EVM to be fully interoperable with the rest of the interchain ecosystem via IVC. This is going to be possible by doing a manual action. So like the user needs to send a transaction to manually convert these tokens. But in the future, we're planning on introducing additional mechanisms so that smart contract can also convert this token natively and send IVC tokens, ERC20 tokens to the rest of the interchain ecosystem by just sending a transaction to a contract that talks to the IVC module. So I'm going to talk about now a little bit development on core development. I'm going to dive a little bit deeper on what's the logic for Evm hooks. The Evm hooks is what I just explained that allows ERC20s to be converted to IVC tokens. So we're introducing this so that the EVM module can basically extend the transaction processing logic. So instead of just targeting the EVM and the state machine and the transaction is processed in the EVM, we also want to execute custom logic so that the EVM can execute additional logic with the staking module, with the IVC module, with the governance module, and thus we can create novel use cases that weren't possible before because of the modularity of the SDK, of the Cosmos SDK. So how this works at a high level, we are defining a log signature that is emitted by a smart contract. So you have an event that is emitted once a transaction is processed, and then the post-transaction logic, this EVM hook for the events, are recognizing these logs according to what's the contract that you're targeting in particular, and then it executes some custom logic so you can execute native calls on Cosmos. So I have a small screenshot here of what's the interface for executing push, like this EVM logic, where you have the Ethereum message, and also, you also have the receives. And the receive from the transaction, once the transaction is successful on the EVM, you can execute some custom logic on the Cosmos side to execute these native calls. And here at the bottom, this is a simple ERC20 logic that we're using for the ERC20 module that is executing basically a transfer from converting or transferring a token to another chain or to another recipient on the Cosmos side. So you can actually emit here at the bottom like a transfer event, and that event is picked up in the Cosmos native module, and then you can execute some custom behavior according to what's the contract that is actually executing these event signature. Now I'm going to talk a little bit about some example projects that I'm particularly very excited about that can benefit from these EVM hooks and also like all the smart contract interoperability that Evmos will provide in the future. So the main use case, and now I'm going back to liquid staking and how staking can be actually improved, is creating sort of like a validator portfolio. So right now, like the user goes to like a block explorer, looks in the validator set, and they usually check, okay, what's the voting power, what's the cumulative share, and then once you delegate your tokens to a validator, usually they tend to stake their tokens with the validators that are higher in the rank because they're providing them more rewards. You can actually, with the EVM, and creating a staking contract, you can actually create a DeFi validator portfolio where you're talking to a contract, and the contract is actually staking those tokens to you, and then actually spreading the tokens across the validator set depending on your preferences, and then automatically distributing or redistributing all these rewards to you or to the same validator set. Or to a completely different one. So you can also create different validator indexes, maybe you can create what are the validators that are carbon neutral, for example, or that are located across the globe, so that you can actually boost the decentralization of the validator set across the different world across the world in case there's an outrage. And finally, one really particular interesting use case that we're talking internally in the team that can also be possible with talking smart contracts with the core EVM is creating staking collateralized loans. So instead of providing collateral for a lending platform, you can actually, when you interact with this lending platform, instead of providing the assets, you can tell them, okay, I'm going to give you an approval to slash my already delegated tokens, so that in case you liquidate me, you slash my tokens instead of, or you collect my tokens from that were already staked. So you can actually migrate those tokens that were already delegated, or you can, for example, slash those tokens that are delegated. So this is creating not a zero collateral DeFi platform, but you're creating some sort of allowance for the DeFi application to actually create this additional functionality for lending platforms. And for the EVM, you can create an EVM ecosystem index. So for example, you can create a portfolio of different IVC coins. How do you manage them? So this can be possible, for example, Sommelier. Sommelier can, it's usually now only targeting the EVM as a co-processor, but you can also create indexes and different portfolio management strategies to how better allocate your portfolio in the different interchain ecosystem by creating strategies on smart contracts that can eventually talk to every specific chain. So that's one example of how you can create smart contracts that are targeting the entire IVC Cosmos ecosystem. We're also currently talking with the Stargaze team on how to create, for example, cross-chain NFTs that are possible to be traded between the EVM ecosystem and also Cosmos WASM environments, which is the WASM framework that we have in Cosmos. And so we can have the same way we have ERC20s coming from these different interoperability clusters, the EVM and Polkadot coming to Cosmos. We can also have NFTs from Solana, for example, or from Avalanche or Polygon that can come to the Cosmos ecosystem via EVM bridges and then be transferred to the rest of the Cosmos through these IVC cross-chain NFT standard that we're trying to implement. And then you also have more complex use case like cross-chain delegate calls, where you don't need to deploy a smart contract twice on different EVM chains, but you can deploy it on Evmos, and then if you have another smart contract that is deployed on another EVM chain in the Cosmos ecosystem, you can send an IVC transaction in order to call the smart contract and then execute some behavior once the packet acknowledgement is processed on Evmos, for example. So you can create interchange composibility through this mechanism right now. So we can forget about the current strategy that a lot of DeFi dApps have at the moment that are deploying in the different EVM chains. which is going to be enabled right now with this cross-chain delegate code that we are going to be providing through the entire interoperability. And the final model is Interchange Composibility. This is a bit different than the example I explained before, which is cross-chain delegate code, so like two EVM chains, or for example, an EVM with a Cosmos WASM smart contract environment that can enable like interoperability between the smart contracts. Here, instead, we're allowing non-EVM chains or any chain in the Cosmos ecosystem to talk to a smart contract natively and get the logs or the events from the receipt directly on their application so that they can handle application-specific logic that is targeting an individual smart contract. So what this is enabling is that you don't need to necessarily build your application-specific logic, and you can scale faster by just deploying a smart contract on Evmos and having all these other chains talk to these smart contracts and then scaling through by only handling the specific events that are targeting the Evmos chains. And then finally, I'm going to talk about all these, the different resources that we have and how you can connect to the Evmos testnet that is currently live, and how you can learn more about Evmos and all the developer documentation that we have, and you can learn more about the architecture. So the first thing is like you can connect already to the Evmos testnet. Here you can find some of the like available nodes, public available endpoints that you can find, which is the Cosmos gRPC, Cosmos REST, which is handled through gRPC gateway. And then you have like the term domain RPC, the Ethereum JSON RPC, so that you can connect MetaMask and on your Ethereum tooling already. And we also support the Ethereum WebSocket through BlockDaemon, which is kindly providing all this infrastructure for the public. We also have like the Evmos chain gRPC gateway docs, so you can already query through this nice interface all the different like RPC, like REST endpoints that you can interact with the Evmos testnet already. So this is actually targeting here. You can see like the base URL is targeting the testnet. And then you can also learn more in our different resources and links that we are providing here. The first of them is our documentation, which you can find on evmos.dev. We have all the documentation of how to connect to the testnet, how to connect to mainnet, which we are relaunching on this Tuesday. And you can also find documentation on how to interact with these REST endpoints or how to run a validator or a node, or how to set up a local net so that you can interact with your smart contract locally. If you want to learn more about like the core development efforts that we're doing, you can go to GitHub and find us on the Tharsis repository on Evmos. We also have a JavaScript library that provides address conversion tools for how to convert bec32 to hex available addresses that Kepler is also using to support Ethereum compatible addresses. And you can also find like protobuf transaction declarations and definitions so that you can send transactions on Cosmos using like Kepler, or we also support, for example, like all the transactions formatted using EIP 712, which is a meta transaction format in Ethereum that allows, for example, MetaMask to sign Cosmos transactions or sending transactions via IBC, so that as a user, you don't need to change your existing wallet to interact with the Cosmos ecosystem, or you don't need to necessarily export your private key. You can already do that natively using this library and connecting MetaMask through EIP 712. And then finally, if you want to know more about the EVM, we have the Ethermint library. Ethermint was the pre-evolution of Evmos, which is a long-standing library for how to develop an EVM module on Cosmos. thank you very much. I'm not sure how much time I have left. I think this is, yeah. Cool. Any questions? Hey, how's it going?
So you mentioned that you are merging the different tokens as, like, I guess, both from EVM, sort of like from Ethereum, let's say like USDC, USDT, USD, whatever,
yeah, and
from IBC. And then, like, if a user wants to withdraw, so to go back, then, like, how do you decide which tokens you will withdraw?
What do you mean drop?
So if I understand correctly, let's say if I move USDC to Evmos, and Amory will send USDT to Evmos, and the Evmos governments decide that USDC is the principal one, then both of us will receive USDC.
Yeah. That's a good question. So he's asking, I'm going to repeat your question so that it gets recorded. He's asking about the ERC20 module and how the registration process is handled, and how the, for example, like the community votes for one smart contract in particular against others, and how do we decide which one is a canonical one and which one is dropped or not from a community point of view, right?
The question is, like, going back. When I'm, like, having the USDC, but originally I provided USDT,
yeah.
Then, like, going back to Ethereum, how do you decide, like, which the users will receive?
Yeah, so for EVM, so like you define a smart contract address, and you define, for example, like which is going to be like the canonical, for example, USDC that is coming from Ethereum to the Evmos chain. That is all voted through governance, and the governance community needs to provide like verifiable smart contract. They need to provide the repository documentation. They need to provide, like, for example, like the hash of the contract, and they need to be like, usually the proposal will have to be proposed by either the developers or some core member users from the community, so that we know that it's actually that development team that is creating that proposal. So there's like needs to be a lot of due diligence from the community in order to actually know what is a verifiable valid contract versus what is just another deployment of the same open source code base, right? And so from the other side, how do you decide like which is going to be like the smart contract representation of a Cosmos asset that will be available in the EVM and then can be transferred out to the Polkadot or the EVM ecosystems? Is once you create the proposal, you can automatically register. We have a factory contract that is gonna, once the proposal is approved, we're gonna deploy a smart contract specifically for that IVC voucher, so that we limit the threat in terms of security of having multiple smart contracts that are not owned by the core team, or the it can be like a fake deployment, for example. So like by creating a factory contract of the IVC voucher, actually it's a core protocol, the owner of or the deployer of the smart contract. So you can create like the approval processes for converting the ERC20 and changing the supply of the token, like minting and burning.
Oh, so let's say that for USD on Evmos there will be like USDV, yes, or USDE, right? Like the merged token for representing various USD tokens. Then if I want to send the USDE back to Ethereum, then I will not receive neither of the original tokens. I will receive USDE, new USDE token on Ethereum.
That is done specifically by whatever breach you're using. So that depends exclusively. We're only handling this from the EVM to the Cosmos representation, but we are not handling how the same representation of the smart contract on the EVM is going to be represented on, say, Ethereum or Polygon, etc. That depends. So there are like going to be like different bridge solutions deploying on Evmos, and the user will have to, based on the trade-off that they find in terms of security, speed, etc. They can select whatever, and also functionality. They can choose whatever bridge provider they prefer.
So will it be possible to bridge into Evmos something that does not have yet official representation, like voted by governance? So I have some random ERC20 token. Can I just bridge it right into Evmos?
Yes. So the question is like, what can I bridge a token that is not voted through governance to Evmos? Yes, so if you're on the EVM ecosystem, on any other EVM chain, and you have like a random ERC20 token, whatever it is, you can use any bridge provider like Nomad, Connects, etc., and you can bridge these tokens to Evmos. But in order to support that EVM, the token in the entire Interchain ecosystem, in the entire Cosmos ecosystem, that token will have to be voted through governance. And the requirements in terms of like due diligence, the entire governance community is going to do is like first having like the contract be verified in the block explorer, for example, that the source code is publicly available and that you're not introducing some malicious action in terms of like, oh, when a token is transferred by a user, you're not, for example, like emitting a ghost approval where you can drain all the user funds. So like the community needs to vote, and that's why we're doing all this due diligence process, but that's only for how to represent the same token as a Cosmos asset and then can be sent back. So that's why we're doing this mechanism through governance. It's in terms of like how to prevent these malicious ERC20s from being deployed on the rest of the Interchain ecosystem.
Okay, so I will be able, with those random tokens, I will be
yes,
able to
you can use any bridge provider.
EVM smart contracts like normally on Evmos, but I will be cut from Cosmos ecosystem.
Yeah, you can use any bridge provider to bridge those tokens to Evmos, and then create your governance proposal to get that token into the rest of the Interchain ecosystem. This, as I mentioned, is just for security measures to prevent malicious ERC20s that drain users' funds because they're not tokens that are necessarily owned by the protocol, but are owned by certain contract owners or deployers. That's why we're trying to mitigate the amount of malicious ERC20s in the ecosystem. Yeah. Well, thank you very much for your time. We'll be here if you have any questions.
Anyone here building on Evmos for the hackathon?